I hope what I'm writing is visible to you, right?
Yes, sir.
8 to 9 marks, sometimes 10 marks around. And the questions, one who is preparing for GATE, he should never leave transportation engineering. That is for sure. Because the questions in transportation engineering are very easy when compared to others. That means they are directly formula oriented questions. What they are? They are directly formula oriented questions.
Yes, sir.
Now, we will say this. Directly, we'll start solving the questions. The first question is, while aligning a hill road with a ruling gradient 6%, that is, you are going on a hilly road with a ruling gradient of 6%, there is a horizontal curve like this, of radius 50 meter. What is the grade compensation required? Ruling gradient is at 50 meter. We have the formula for grade compensation as, what is the formula for grade compensation? Tell me.
30 plus R by R or 75 by R, which is least from these values.
Good. So what is initial value 30 plus R by R? How much it is?
Just a minute. 80 by 50. So 1.6.
30 plus R by R is 30 plus 50 upon 50. It's 80 by 50. It's 1.6, or 75 upon 50. That is 1.5. So which should we take? Take note. Tell me.
1.5.
1.5.
Yes, sir.
Now, after this,
Sir, after this,
we got the grade compensation as a 1.6 percentage as a, or 1.5 percentage. We need to use the minimum value itself then. So 1.5 percentage.
yes, sir.
So what he asked us is grade compensation itself. Therefore, it is 1.5%. Now, in some questions, they will be asked us after compensation, what is the required grade? That is compensated grade. Sometimes they will be asking us what is the compensated grade. That is Z initial grade minus ZC.
Yes, sir.
Z minus ZC. What
Yes,
is
sir.
Z minus ZC here? Tell me.
Sir, G minus GC, sir. 6 minus 1.5.
Minus
3.3
1.5. That gives
point.
us 4.5%. So what
Yes,
are the grade we get? We need to check it whether it's less than 4%, sorry, greater than 4%. Yes or no?
yes, sir.
Yes. If it is less than 4%, for suppose if you are getting here a value of 3.8, 3, or any value less than 4, you need to take it as 4.
Yes,
Okay.
sir.
Instead of 4.5, if you are getting any value greater than 4, you need to take it as 4%.
Less than 4.
Yeah.
Yes.
If you are getting a value less than 4, you need to take it as 4%.
Percent. Okay, sir.
Anything greater than 4, you take the value what you got.
Yes, sir.
Because the reason is grade compensation is not required for gradients flatter than 4%.
Yes, sir.
Okay. Let's say this. Motorist traveling at 100 kmph on a highway needs to take the next exit, which has a speed limit of 50 kmph. The section of the roadway before the ramp entry has a downgrade 3%. Coefficient of friction is 0.35. Coefficient of friction is 0.35. In order to exit the ramp at maximum allowable speed limit, the braking distance from the exit ramp is how much?
Braking distance.
Now, here we need to see hopping side distance is equal to lag distance plus braking distance. What is lag distance?
Sir, time. Sir, the distance traveled during before,
Reaction time
yes, before application of brakes.
plus braking distance, that is after application of that brakes.
Yes, sir.
V square by 2ZF.
Yes, sir.
Vt plus V square by 2ZF. So this is lag distance, and this V square by 2ZF is our braking distance. Now, in
Yes.
order to enter, the motorist traveling at 100 kmph on highway need to take the next exit, which has a speed limit of 50 kmph. The section on the road has a downgrade 3%, coefficient is 0.35. We have section before the ramp has a downgrade also he given.
Yes, sir.
That means here he is also having some slope. So whenever we have this formula is applicable for this one. What it is? This formula is applicable,
Straight roads.
yeah, for flat roads. What? But whenever we have some gradient changes, then the formula becomes Vt plus V square upon 2z into F eta plus or minus n percentage.
Yes, sir.
For ascending gradient, use plus. For descending gradient, use minus.
Yes, sir.
This eta is braking efficiency. When it does not talk about braking efficiency, assume it is 100%, take it 1. In the question, he have not mentioned about braking efficiency. So let's take it 1. But he had mentioned a downgrade. How much is it?
-3.
So F minus N. So the formula becomes SSD is equal to, first formula for stopping side distance becomes SSD is equal to Vt plus V square upon 2Z into F minus N percentage. We not N in percentage. We need to convert this N to decimal.
Yes, sir.
Okay. Now what he asked us, tell me the braking distance. He asked us the braking distance.
V square by 2g into F minus n.
Yes. What is the braking distance? That is V square by 2Z into F minus N. Try this.
Yes, sir.
Else give me a minute here. But here, listen, before
Sir.
trying, just give me a minute here. Every time we expect braking distance means reduction of the speed to zero.
Yes, sir.
Yes or no?
Yes, sir.
Reduction of the speed to 0. But here, the speed is not reducing to 0. The speed is reducing from 100 kilometer per hour to,
50 km/h.
so just it should be the difference. Braking distance here will become V2 square minus V1 square upon 2z into F minus N. Now, initially, you need to convert this 100 kmph to meter per second, 50 kmph to meter per second. In order for the conversion, multiply it with 5 by 18.
Yes, sir.
V2 equal to, or else let's take it V1 square minus V2 square. V1 is initial, V2 is final.
Sir.
V1 is 100 into 5 by 18. How much it is?
To 27.277.
78. Okay. Meter per second. And how much is V2? Whenever I'm writing small v, velocity in meter per second, capital V, velocity is in kmph, or else capital V is volume. How much is this then?
Sir, 13.88. 13 point, yes.
88.
13.89.
Yeah, 13.89. So we got them uh 27.78 square minus 13.89 square upon 2 into 9.81 into F is 0.35 minus 0.03. Can you tell me the answer?
Yes, sir.
Calculations will be easier than than the previous one.
Sir, 92.188.
92.19 meter. Am I right?
Yes, sir.
The range of the answer will be like 91.8 to 91.7 to 92.7 meter. So any value in this range, your answer will be right.
Okay, sir.
Okay,
Yes, sir.
shall we move forward?
Yes, sir.
Once let's try this. Let's give a try for this question.
Yes, sir.
Look at it.
Yes, sir.
This is the question specifying us. Two cars P and Q are moving in a racing track continuously for 2 hours. Okay, they are moving in a racing track continuously for 2 hours. Assume that no other vehicles are using the track during this time. The expressions relating the distance traveled d in kilometer, time in hour for both the vehicles given are for P, car P, d equal to 60t. For car Q, d equal to 60t square. Within the first 1 hour, the maximum space headway would be, tell me, t is in hours. For suppose he is asking us the maximum space headway. That is, if there is a car P here, car Q here, what is the maximum space that can be between both the cars in first 1 hour?
Okay, sir.
Okay. That means always between the car P and car Q, whichever might go first, whichever might go later, but there will be some difference. Yes or no?
Yes, sir.
Because both the functions in distance are not the same. This is
Yes,
60t and this is 60t square. There
yes,
is
sir.
some difference.
Yes, sir.
So always the difference in distance traveled, the difference in distance traveled is equal to, this one is 60t square minus 60t. Yes or no?
120, sir.
No, no. I'm just we are just talking about the distance. That distance we call it as space. Yes
Okay,
or
sir.
no?
Yes, sir.
At any point, this will be the distance maintained.
Yes, sir.
Okay.
Yes,
And
sir.
for space to be maximum, when is this space going to be maximum?
ds by dt
Very good. Very good. Super.
equals to
ds
0.
by dt equal to, for s to be maximum, ds by dt equal to 0. Now,
120.
6
Yes.
d by dt, 60 into 2t,
120 t
120t minus 60,
t equals to 1 by 2.
t is equal to 1 by 2. It is in hours, yes or no?
Yes. Yes, sir.
Because time is in hours.
Yes, sir.
Now, at this t equal to 1 by 2, what is the maximum space headway? Maximum space headway is equal to 60 into 1 by 2 whole square minus 60 into 1 by 2. 60 into 1 by 4, 15. Minus 60 into 1 by 2, 30. That's minus 15.
Yes, sir.
Very good. Minus 15 is right because that is nothing but the space. Here we are taking Q minus P. That is, we are assuming Q is in front of P, but
Yes,
we
sir.
got minus. That is, P is in front of Q.
Yes, sir.
But whatever it might be, we have the distance. We require the space only. So that is 15 kilometer. At what time? Space is 15 kilometer. We have two options matching. At what
30,
time? Half an hour.
30,
Half an hour means,
30 minute.
so option A will be our answer.
Yes, sir. Okay,
Have a
sir.
look at it. We'll move on to the next question.
Space headway is difference in distance. So, sir, space headway means the difference in distance traveled by both of them.
Anytime space headway means nothing but spacing between both the cars.
Okay, okay, sir. At any time.
At any time. Any other
Okay.
doubt in this? We know the
No, sir.
maximum minimum functions.
Yes, sir, yes, sir.
ds by dt equal to 0.
Yes, sir.
Yeah. See, this is a bit critical. That is somewhat different kind of question.
Traffic crossing an undivided two-lane to crossing priority intersection has a single lane, one way. Crossing Traversing speed on single lane road is 20 km per speed on
Don't solve. I'll tell you how to solve. Just have a look at the question. Listen.
Yes, sir.
What is the question stating? There is a priority intersection has a single lane one-way traffic crossing a undivided two-lane two-way traffic road. Okay.
Yes, sir.
So in general, there is an intersection. Yes or no?
Yes, sir.
There is an intersection. One is a minor road. Single lane one way traffic road is our minor road. Okay.
Yes, sir.
And the two lane road will be our major road.
Okay, sir.
Always. That is, road of least importance will be our minor road. Road of major importance will be our major road.
Okay, sir.
Next, the traffic stream on single lane road is 20 kmph. On minor road, a vehicle should travel at what speed?
20
20
kmph,
kmph. Speed on two lane road is
50 kmph.
50 kmph. Now, what is mentioned now? Tell me. Perception reaction time is 2.5 seconds. Reaction time 2.5 seconds. Coefficient of longitudinal friction F is given 0.38. T is 2.5 seconds. Z is given to you 9.81 meter per second square. A clear side triangle has to be ensured at the intersection. That is, at the intersection, there should be a clear side triangle that he is mentioning. That is, whenever there is a car or vehicle over here, it should see the vehicle at this point. So that should form a clear side triangle. Understanding?
Yes, sir.
So the minimum length of the sides of the side triangle along two lane road and single lane road. That is, from here to here, what is the minimum length? L1. And for here, from here to here, what is the minimum length? L2. He is asking us.
Yes, sir.
Okay. Now
Yes.
listen. Let's calculate. Calculate this one. L1. What is L1? Tell me. Along the major road. Length along the major road. What it is? Vt plus V square upon 2ZF.
Yes.
What is V? 50 into 5 by 18. How much is it? Always do this calculation sideways. Don't involve it in this.
Yes. Sir, 13.89.
Very good. As you told me in the previous problem also. 13.89 into 2.5 plus
335.66.
what it is, ma? V square.
V square by 2GF.
Okay. Is it what we have?
Yes, sir. Okay.
Or tell me once, let me calculate this.
25.87.
25.8788
Yes.
plus
Plus 25 plus 13 into 0.89.
we are getting 60.6.
Yes, sir. 60.6.
60.6 meter. That is L1. Next, let's calculate L2. How much is L2? This one, similarly, 20 into 5 by 18, that is in V2. That is your V2. Reaction time is 2.5 plus plus what is 20 into 5 by 18? Tell me.
Sir, 5.56.
V square 5.56 square upon 2 into 9.81 into F is 0.38. Tell me the answer.
16.64.
I'm getting 18.04. 5.56 into 2.5 is 13.9.
Yes, sir.
5.56 square upon it's 14.4.14 is the second term. So we are getting 18.04.
Yes, sir.
18 meter. Do we have an option?
Yes, sir.
Shall we
60.
shall we go with it?
Yes, sir.
Yes. Listen, but there is some mistake in this. Our option is wrong.
Why, sir?
I'll tell you. I'll tell you. Mhm. This holds good if uh, it is like roads are of both the roads are of same importance. This holds good with if both the roads are of same importance, or else we are considering a single road.
Okay.
Are you understanding, my dear? If this is
Yes, sir.
also a two-lane highway, this is also a two-lane highway, both of same importance, we can go with it directly.
Okay.
Understanding?
Yes, sir.
But uh, when we have roads of different importance, that we call it as priority intersection.
Okay, sir.
In the question, first line itself, what he told us?
Priority intersection.
When we are talking about priority intersection, the minimum distance, that is, when we have a side triangle, the length on the minor road should be, minimum should be 15 meter. How much it is? No need of calculating. On priority intersection, the minimum distance of side triangle on the minor road is how much?
15 meter.
As per IS 1976.
Okay, sir.
And next, this should be done. How is the major distance calculated? Minimum side distance on the major side of the triangle calculated is, we know V1
Yes, sir.
into the reaction time.
Yes, sir.
Where in this also we assume, or not the reaction time, we assume it as complete time for breaking. This should be considered 8 seconds. How much it is? Default.
Eight.
How much it is given? It's default for us. How
Okay,
much
sir.
is the time we will be considering it?
8 seconds.
8 seconds. So what is V1? 13 point
8, 9,
into,
8.
this is in meter per second, this is in second. What is the answer now?
111.12.
So what is our answer now? Maximum length will be 111 meter. Minimum length should be
15 meter.
99% of the people who see this question go with the answer what we done. Yes or no?
Yes, sir.
But those who learn this concept only will do this problem.
Yes, sir.
What it is? Concept of priority intersection. If this word is not there, then 100% option B is our answer.
Yes, sir. Sir, the time we take in priority intersection, the time we take 8 seconds
8 seconds
as per IRC.
as per IRC.
Yes, sir.
On the major road.
Yes, on major road.
On major
And
road.
what about, sir, minor road?
Minor road, directly we take the distance itself as 15 meter.
Yes, sir. There is no provision for time in.
Not required. Directly we take the distance.
Yes, sir.
Okay.
Like if
Yes, yes.
we if there is a need to calculate velocity, then velocity in minor road, then at that
Velocity in
need
minor road. Okay. Then
at
they will
that.
specify you the time to be considered.
Yes, sir. Okay, sir.
Yes. There is such no such fixed value. This should be considered.
Okay, sir.
Shall we move forward to the next question?
Yes, sir.
Any doubt in this, please let me know,
Also,
please.
it is clear, sir.
Let's do this. A car follows a slow moving truck at a speed of 10 meter per second on a two-lane two-way highway. The car reduces its speed to 10 meter per second and follows the truck, maintaining a distance of 16 meter from the truck. On finding a clear gap in opposing traffic stream, the car accelerates at an average rate of 4 meter per second square overtakes the truck and returns to its original line. When returns to its original line, the distance between car and truck is 16 meter. The total distance covered by the car during this period, that is from the time it leaves the lane and subsequently returns to its lane after overtaking, is dash meter. How to do this?
Sir, we need to calculate D2.
Yes, D2. Very good. OSD is a sum of
Sir,
D1
D1.
plus D2 plus D3. In this, we don't need to calculate D1 because already what it is mentioned, car is not moving at high speed. Car has already reduced its speed to that of the slow moving vehicle, truck speed. So no
Yes,
need
sir.
of calculating D1. Am I right?
Yes, sir.
So initially car A is here, car B is here. During the overtaking operation, sorry, truck B is here. During overtaking operation, truck B is traveling from this distance to this distance. In this overtaking, after overtaking, car A is again coming to this position. This is 16 meter initially, and after overtaking also, the distance between truck and car is 16 meter. But we
Yes, sir.
want the total distance.
Yes, sir. 16 plus 16 plus D2.
So let's
D2.
calculate B first.
Yes, sir. 10 into 10 multiplied by.
That is nothing but VB into T.
Yes, sir. 10 multiplied by 16.
B is nothing but VB into T.
Yes,
What
sir.
is VB then? Slow moving vehicle speed. What is the slow moving vehicle speed?
10 meter per second.
10 meter per second
Yes, sir.
into T is how to calculate T?
4 under root 4s by.
4S by A.
Yes, sir. A. Under root 4s by A.
What is S then?
Yes, sir. 16 meter.
Very good. A is how much more? Meter per second square.
Yes,
Acceleration.
meter per second square. Yes, sir.
So root 16 is
4.
4 seconds. What is small b then?
40 meter.
40 meter. And but is he asking a small b or a D2?
Sir, D2.
D2 is the summation of
32.
S1 plus small b plus S2. S1 is
72.
16 plus b is 40 plus S2 is 16. So
70.
16, 16, 32 plus 40 is
72.
72 meters.
Yes, sir.
Shall we move forward?
Yes, sir.
Tell me the answer for this. Do
Cooking
this.
the
You can do this on your own. Take 5 minutes and tell me the answer.
for the cooking. Sir, I am getting g by f eta plus 2g into 100.
0 by,
F eta plus 2g into 100.
we will check. We will check. Don't worry. Listen,
Yes,
the
sir.
coefficient of average rolling friction of a road is FR, and its grade is plus Z. Grade of this road is doubled. Change in braking distance along the horizontal. Okay, so change in braking distance is nothing but BD2 minus BD1. Am I right?
Yes, sir.
Into 100.
Yes, sir.
Percentage. Initial braking distance into 100.
Yes, sir.
So what is BD2 now? Tell me.
Sir, BD
BD2 is
v square by g f eta plus 2g.
2Z into F.
Eta,
Efficiency, is it mentioned?
it is 1, sir. It will be 1.
Eta is 1, not mentioned.
Yes, sir.
Plus Z. But it is 2Z, right?
Yes, sir.
It is 2Z
Yes, sir.
minus V square by 2Z into F plus Z upon V square by 2Z into F plus Z
Yes, sir.
into 100. So can I cancel out V square, 2Z,
Yes, sir.
all the things?
Yes, sir.
So I am left with 1 by F plus 2Z minus 1 by F plus Z upon 1 by F plus Z. Yes or no?
Yes, sir.
So in the, wait, instead of Z also, we need to have it in percentage. So it is 0.01. This is 0.01. Am I right?
Yes, sir.
Because in the previous problem also, when you have 3%, what is that we considered? Tell me. 0.03. Let me show this to you. Listen, here downgrade ramp entry of 3% we have. How
Yes, sir.
much we considered?
0.03.
Always we need to consider it in decimal. So that means
So,
Z also should be multiplied with
yes, sir.
0.01.
Yes, sir.
That means divide Z with 100.
Yes, sir.
So coming to the numerator, this multiply with F plus 0.02Z on one side, and this we have it as F plus 0.01Z. So no, I'm multiplying both the things. 1 by
Yes, sir.
x minus 1 by y minus x by xy. Yes or no?
Yes, sir.
So that is f plus 0.01z
Minus
minus f
minus 0.02g.
minus 0.02z.
Yes, sir.
So f and f gets cancelled.
Minus 0.1g.
Wait, yeah. 1 by f plus 0.01z.
Yes,
Yes
sir.
or no? We have it in the bottom. Can I
Yes,
cancel out this one and this one?
yes, sir.
So what are we left with? Tell me.
Sir, we are left with minus 0.01g by f plus 0.02g.
Minus 0.01z upon f
F plus
plus
0.0.
0.02z the
Yes, sir.
total change into 100. Yes or no? Since we have 100 here also,
Yes, sir.
don't be worried now. Uh, we have 0 point. This is the change. Yes or no? So change can be either positive or negative.
Yes, sir.
So what is the matching answer then?
C.
That means instead of BD2 minus BD1, we should have taken BD1 minus BD2, which
Yes,
will
sir.
give us option C.
Yes, sir.
Clear?
Yes, sir.
Just give me a minute here. I need to restart my presentation list.
Okay, sir.
Now, let's do this. A vehicle is moving on a road of grade 4% and speed 20 meter per second. Gradient is given, speed is given, coefficient of friction is given, acceleration due to gravity is given. On applying brake, to reach a speed of 10 meter per second, required braking distance. Already we have solved such kind of question. Can you do
Yeah,
this?
yes, sir.
What is the formula for braking distance?
V1 square minus V2 square
Very good. V1 square minus V2 square
to
upon 2Z
G
F
E plus A plus N.
N. Good. N, how much you need to take? Don't take 4 directly. It need to be taken as.
0.04.
Very good. Hmm.
Sir, 3.43.
3.43. What it is?
Sir, breaking
20
this.
square is 400 minus 10 square is 100, right?
Sir,
2 into 9.8. Let's take it 10, he told you. Into 4. This is 0.46 plus 0.04.
okay.
0.50.
Sorry, sir. I mistakenly substituted value of G as 4%.
I reminded initially about the same.
Yes, sir.
That's a common mistake what we do actually.
Yes, sir.
300 upon 10. Answer is
30.
3 meter is very small.
Yes, sir. Yes, sir. Yes, sir.
Shall we move forward?
Yes, sir. Sir, do we have some questions which are recently asked in recent years? Like,
Yeah,
we have discussed some questions of 2019.
okay.
See,
We will do now. We will do. Not a problem. Else we will do one thing. We will do them tomorrow.
yes, sir. Yes, sir.
23,
Uh,
24. These questions we will do tomorrow. Not a
yes.
problem.
Yes.
Let's do this super elevation question. Listen. The radius of a horizontal curve is given as 120 meter. So this is r
Yes,
is equal to 120. Design
sir.
speed 60 kmph. This need to
Yes,
be converted now.
sir. 5 by
60
18.
into 5 by 18. How much is it? 300 upon 18 is
Sir, 16.67.
meter per second. Design coefficient of lateral friction between tire. Lateral friction
F.
X comes under picture during skidding in horizontal curves. Okay. Till now, what we discussed is rolling friction.
Yes, sir.
The estimated value of super elevation required if full lateral friction is to be developed. Okay, full lateral friction is developed, he told. And value of coefficient of friction if no super elevation will be provided. Both the things we need to carry out. Okay.
Full friction means F equals to 1.
F equal to 0.15.
Okay,
F
okay, sir.
equal to 0.15. Not n is equal to 1. That's not our criteria. Now, in super elevation, we have the formula E plus F is equal to V square upon ZR. What's our formula?
Yes, yes. E plus F equals to V square by GR.
First, we will be calculating super elevation. How much is required? So F is how much initially? Full friction means how much is the full friction we have?
0.15.
0.15. That is equal to 16.67 whole square upon G is 9.81 into R is how much?
R is 120 meter.
120. So E is how much? Calculate and tell me the value of E.
So 0.09.
Divide it with 1 because we have it in fraction. Here we want the exact answer rather than 0.09. If you can tell me 0.08 something, that will be more beneficial. That is, I want the three digits here.
So 0.086.
Okay,
0.08.
divide it with power or else do one thing. Go for it with power minus 1. Inverse it.
Okay, sir.
I'm getting 0.08606.
Yes, sir. 0.08606.
Yeah. So
Yes,
when
sir.
I'm doing the inverse, I'm getting it as so the same whatever you got 0.086. Can I write it as 1 by 11.62?
11.62.
How do you get it? Is take power minus 1, you will be getting 11.62
0.086.
to the power of minus 1. Inverse it.
Yes, sir. 11.62.
So friction is 11.62 in this case
Yes, sir.
and 1 by 11.6 in this case. So we are left with one more thing. Directly I can pick answer C, option C. Why? Because I have already told you a trick previously. 11.6, two things are repeating. And here
Yes,
also two things are repeating. So our matching answer is
yes, sir. Point two
answer
four.
C. That is one reason without any technical reason. And next reason is coefficient of friction developed needed. No super elevation is acting. That is E goes to 0, F is equal to V square by ZR. Now tell me. E
16
goes to
point.
0, F is equal to V square by ZR.
Yes, sir. Divided by.
That is, one thing is sure, the super elevation should be when E is 0, this F should counteract for super elevation also. That is, F is greater than 0.15. Yes or no?
Yes, sir. Yes, sir. Yes, sir.
When 1 by 11.6 you have, we have two options,
Yes, sir.
0.10, 0.24. So which is the answer now?
Sir, answer would be 0.24, greater than 1.5,
Yeah,
0.15.
that's it. Or else let's calculate in this fashion again. Calculate and tell me how much you are getting F when E goes to 0.
Sir, 0.23.
0.23 something,
0.236, that is 2.24.
0.24.
Yes, sir.
Any doubts in this?
No, sir.
Let's do this one. A 7.5 meter wide. 7.5 meter means it's 100%. One
Lane,
lane is 3.5 meter. 100% two lane road. Yes or no?
two lane, two way.
Two lane two way road with a road divider.
Yes, sir.
A 7.5 meter two lane road on a plain terrain is to be laid along a horizontal curve of radius how much?
510 meter,
510 meter for design speed
100 kmph.
100 kmph. Super elevation is provided. Consider acceleration due to gravity. Let's leave this code. We don't need to do anything with this.
Yes, sir.
The level difference between inner and outer edges of the road is dash.
True difference between and outer edges of
That is nothing but the super elevation.
the super elevation.
Yes.
One
Now,
is to
now
sir.
is laid along a horizontal curve. There should be given mixed traffic here. Wait. Okay, okay. What are we asked to calculate? Tell me.
Sir, it is capital E or small e. The level difference.
First, let's calculate small e.
Small e.
See,
E square by 2g.
this will be what we are getting.
Yes, sir.
A, B, C. Okay. and the width is 7.5 meter,
Yes, sir.
and this is theta equal to tan theta. That is equal to how much? Finally, I want BC. Level difference between inner and outer edge means I want BC.
Yes, sir.
First, let's calculate E.
Yes, sir. Sir,
Is F
with the
given?
no, sir, we can use formula E equals to V square by GR.
E plus F is equal to V square by GR, right?
Yes, sir.
But when F is not given, when he is specifying design speed, design super elevation, F is not given, what
Yes,
we
sir.
consider is, assume it to be 0,
Yes, sir.
E is V square upon
GR.
225R. What is the formula we take?
Okay, sir. V square by 225.
Capital V square. This V square by ZR, I can write capital V square by 127R also, where capital V is the velocity in kmph.
Yes, sir. Okay, sir.
Okay. Here, but when it comes, when we don't have F, we can take it as E equal to V square upon 225R.
Okay, sir.
Okay.
Yes,
Only
sir.
when you don't have friction only, then only you can take this. This is actually for mixed traffic condition or design condition.
Yes, sir.
What in condition we have? Mixed traffic or
Design gun.
design speed condition.
Yes.
And that means in mixed traffic condition, we take V as V design. Here also we are taking V, the same V design only.
Yes.
So directly take it as 100,
Yes, sir.
100 square by 225 into R is 510. Tell me the answer for this.
Sir, 0.09.
So check out once again. 0 point. Yes, yes, yes. Tell me 0
Sir, 0.09.
0.09.
Yes, sir.
Now, here we need to check. When we are going through this design conditions, we need to check, is E greater than 0.07?
Yes, sir.
Yes or no?
Yes, sir.
Yes. Then
Yes, sir.
take E equal to 0.07 only. In
Okay, sir.
design conditions, E design should be limited to how much?
0.07.
0.07.
Okay, sir.
Because greater is the super elevation also, there is a chance of the vehicle falling down.
Yes, sir. Yes, sir.
Okay. So we
First.
limit it to 0.07. We always limit F to 0.15. Do remember both the things.
Yes, sir.
During design only.
Okay, sir.
Now, I know this tan theta 0.07. I know this as 7.5. What is X then? Tan theta equal to BC by AB.
Sir, X by
0.07 is equal to X by 7.5.
yes,
What
sir.
is X?
0.07 multiplied by 7.5. Sir, 0.525 meter.
0.525 meter.
Yes, sir.
That will be our answer.
Yes, sir.
Shall we go to the next question?
Yes, sir.
Tomorrow I'll prepare some questions for you. For you, we will do that only. Our latest year questions we'll be doing.
Yes, sir.
Let's do this. What are we asked to calculate?
Sir,
An
often
isolated three-phase signal is designed by Webster method. The critical flow ratios for these three phases are 0.2, 0.3, and 0.25. That is, we denote critical flow ratios as y1 is equal to 0.2, y2 for second phase 0.3, y3 0.25. Total how many phases we have?
three.
Three phases.
Yes, sir.
Okay, what is the lost time per each phase?
4 seconds.
So what is the total lost time L?
Sir, 12 seconds.
4 into 3,
Yes, sir.
12 seconds. Optimum cycle length is given by the formula 1.5 L plus 5 upon 1 minus Y. Y is nothing but the combination of all the things.
Yes, sir. Y equals to 0.2 plus 0.5.
1 minus 0.2 plus 0.3, 0.5 plus 0.75, 0.25, 0.75.
2, 12 plus 5.
Are the calculations simple today, as I told you?
Sir, yes, sir. Sir, 92.
92 seconds.
Yes, sir.
Okay, let's do this. Listen,
Yes, sir.
the total number of commercial vehicles per day ranges from 3,000 to 6,000. Minimum percentage of commercial traffic to be surveyed for axle load is. It depends on a few parameters. That is, if commercial vehicles less than 3,000. Next, so percentage of traffic surveyed should be more 20%. Okay. If the vehicles lies between 3,000 to 6,000, we can survey only 15%. If the vehicles are greater than 6,000, we can go for only 10% of the survey.
Yes, sir.
No, now what is our answer now? Tell me.
The minimum percent of commercial traffic.
Anything you can eliminate these two things safely.
15, sir.
15 is our answer.
Yes, sir.
And
Yes, sir.
okay, let's do this. Read this question and try to do this. Take a couple of minutes. Wait. Sorry, let's leave this one. This is the continuation of other question. Let's leave about it. Let's do this. Okay. What is given?
So jam density
The
and
space
flow.
mean speed, density of a are linearly related. He told you. He told us.
Yes, sir.
Okay. So when we take space mean speed and density, both are linearly related. Yes or no?
Yes, sir.
That is, when you have maximum density, speed is zero.
Yes, sir.
Yes or no? Sorry. Mm, let's leave about it. Look at it. At maximum density, when the vehicles are maximum, you will be go to a speed of zero. Yes or no?
Yes, sir.
When is the vehicle maximum? At red light stopping condition.
Yes, sir.
When you have maximum speed, the density will be very lesser.
Yes, sir.
So the free flow speed and jam density are given as so maximum density is given to you 80.
Yes, sir.
That is jam density is Kj 80. Sorry, jam density is Kj. J means jam, K means density. 100
Yes,
vehicles per kilometer. Yes or no?
yes, sir.
Free flow speed is given to you Vf 80 kmph.
Yes, sir.
When he is telling you linearly related, we go with Greenshield's macroscopic model.
Okay.
What it is?
Greenshield's macroscopic model.
Greenshield's model simply, or else.
Yes, sir.
We go with Greenshield's model.
Yes,
That is given by V equal to Vf into 1 minus K upon Kj. So, what is traffic flow corresponding to speed? Vehicles per hour. So, first we will find out Q, K. We will find out density. Then traffic flow Q is equal to KV. Okay.
yes, sir.
Now, yet what speed we require? 40
40.
kmph. So, 40 is equal to Vf is how much? 80. 1 minus K by Kj is how much? 100. Tell me this. K is how much from this? How much vehicles per kilometer?
Fifty. 50 vehicles per kilometer.
From this Q is equal to KV. K is 50 vehicles per kilometer. V is how much? 40. Because corresponding speed is 40, right?
Yes, sir.
40 kilometer per hour. Always flow will be in vehicles per hour. How much is the answer?
200, sir.
2000.
2000. 2000 vehicles.
2000 vehicles are traveling for that road for 1 hour.
Yes, sir. Per hour. Vehicles per hour.
Shall we go forward?
Yes, sir.
Try this.
Yes, sir.
Take a minute and try this.
Sir, which topic question is this, sir?
Yeah, sorry for this trouble. Am I audible to you? Am I audible to you? Please respond.
Yes, sir.
Okay. Yeah. This is from traffic engineering.
Okay, sir.
Uh, the maximum number of vehicles observed in any 5 minute period during the peak hour. In any 5 minute period during the peak hour, you are getting how many vehicles?
160.
160. If the total flow in the peak hour is 1000 vehicle, the 5 minute peak hour factor is how much? So 5 minute peak hour factor is defined as ratio of peak hourly traffic for 5 minutes to maximum possible traffic for that 5 minutes. So how we do this is, listen, what are we required? That we require? Tell me.
5 minute peak hour factor.
5 minute peak hour factor. Let it be 5 minute peak hour factor. 10-minute peak hour factor, 15-minute peak hour factor, it doesn't matter to us. Okay.
Yes, sir.
What we do is peak hour flow. For suppose, what do you understand by peak hour flow? Generally during evening 5 o'clock to 6 o'clock, that is the time in hour, the time for an hour where you have the maximum traffic, peak flow. We call
Yes,
it
sir.
as peak hour flow. Yes or no?
Yes, sir.
Upon for suppose if you are given 15-minute period, how many 15 minutes are there in 1 hour? Tell me.
Sir, 4.
60 by 15, man.
Yes, sir. 4.
Or
Yes, sir.
so similarly, how many 5-minute periods are there in 1 hour?
12.
Well, great, good. So peak hour flow upon 12 into maximum number of vehicles observed during that 5-minute factor. How much is it?
12
5-minute
into.
traffic.
Yes, sir.
Okay, 5-minute maximum traffic.
Yes,
So
sir.
peak hour flow is 1000 upon 12 5 minutes at such times are there. Peak hour is 160.
Yes, sir.
5-minute peak hour maximum traffic is 160. What is the answer then?
Sir, 0.521.
0.52 then, right?
Yes, sir. Yes.
Or suppose if it is given 15 minutes, if it is given 400, what is
Yes.
the formula then? Tell me.
So 15-minute period.
The 15-minute peak hour factor is asked. So the 15-minute peak hour factor is equal to
Peak
peak
hour.
hour flow upon how many 15-minute periods are there?
Sir, 4.
4
4 in
into 15-minute traffic,
maximum traffic.
maximum traffic. Good. Super. Peak hour flow is 1000
So
upon 4 into maximum 15-minute traffic is how much?
100.
400. 1000 upon 1600.
Yes, sir. 0.625.
Understood how to solve such problems?
Yes, sir.
Clear?
Yes, sir.
This is a very simple question. Average free flow and jam density for a road stretch. VF KZ. VF is given as 60 kmph. KZ is given as
20 vehicles per.
120 vehicles per kilometer. Linear speed density model. Maximum flow. Qmax is equal to VF happens at VF by 2, Kz by 2. That is VF Kz by 4. Directly remember the formula.
Yes, sir.
VF is how much? 60 into Kz is 120 upon 4. 430 is 1800 vehicles per hour.
Yes, sir.
Understood?
Yes, sir.
Only this occurs, we can use this formula when the
Linear
linear
speed
speed density relationship is
problem.
linear.
Yes, sir.
When the speed density relationship is
Linear.
linear. Let's do this. Look, traffic on highway is moving at a rate of 360 vehicles per hour at a location. Q is given to you. How much?
60 per hour.
360 vehicles per hour.
Yes, sir.
Okay. If the number of vehicles arriving on this highway follows with the distribution, Poisson's
Poison.
distribution,
Yes, sir.
this way Q, you can also write it as lambda, especially when you consider Poisson distribution. Okay.
Yes, sir.
The
Yeah.
probability that headway between two successive vehicles lies between 6 and 10 seconds. That is, he is asking time headway.
Yes, sir.
So, time headway is always given by the factor. First, let us find out lambda. That is 360 vehicles per hour. Yes or no? But he is asking us the time headway in hours or seconds or minutes.
Seconds.
So let's convert this 360 vehicles per hour to seconds. 1 hour is 60 minutes, 1 minute is 60 seconds.
One. One vehicle per second.
0.1
Vehicle per second.
vehicle per second. Am I right?
Yes, sir.
So that is now what I can write is s- number of vehicles arriving and Poisson's distribution always have the formula f of x is equal to lambda into e power lambda x. What it
Yes, sir.
is?
Lambda e power minus lambda x. E power
Yeah,
lambda.
lambda e power minus lambda x. Sorry. Very good. Very good. 0.1 e power minus 0.1 x. Am I right?
Yes, sir.
So the probability it's lying in between x
Zero.
lies between 6 to 10 seconds is e power minus lambda into x is 6 minus e power minus lambda into x is 10.
10.
This is function. Don't get this point one to this probability equation. Not required. Okay. E power lambda is 0.1 for us.
Yes,
Vehicles
sir.
per second into 6 minus 0.1 into 10. Tell me the answer. Very simple, ma. Even if you don't remember all these things also, remember this formula. Poisson distribution e power minus lambda x1 minus e power minus lambda x2. That's it.
Yes, sir. E power
Am I
minus.
dumping too much?
No, sir.
Okay. Sorry for using the word dumping. I am supposed to use am I feeding too much at this point of time.
No, no, sir.
I used it by mistake.
No problem. Sir, answer is 0.181.
Very good. Very good. Super. That probability is 0.18. Tomorrow we will do only mostly the questions after 2020
Yes, sir.
in transportation.
Okay, sir.
Let's do this. The uniform arrival and uniform service rates on an approach road to a signalized intersection are 20 vehicles per minute. Uniform arrival is 20 vehicles per minute. Uniform service rate is 50 vehicles per minute. For this signal, the red time is how much? 30 seconds. Effective green time is how much? 30
What
seconds.
is it?
Cycle length is 30 seconds. Assuming initially there are no vehicles in queue, average delay per vehicle using the approach road during the cycle length in seconds is. This is actually, we use an equation here for finding average delay. We use which equation? Webster's equation. We mention average delay, use Webster's equation. Okay.
Okay.
That is
Okay.
given by the formula C naught upon 2, 1 minus Zi upon C naught whole square upon 1 minus Qi upon Si. The formula clear?
Yes, sir.
C naught upon 2, 1 minus Zi upon C naught whole square upon 1 minus Qi upon Si. What is C naught? Total cycle length.
60 seconds.
C naught is total cycle length 60 seconds by 2. 1 minus what is Zi? Green length. Green time.
Green time.
30 seconds.
Second.
Effective green time.
Yes, sir.
Upon C naught 60 whole square upon 1 minus what is Qi? Qi means uniform arrival. How much is Qi? Uniform arrival is how much?
20.
20. How much is uniform service rate total flow?
50 vehicles per minute.
50. Calculate it and tell me the answer. That's it. Only the formula gives you the marks.
Yes, sir.
If you remember the formula, you can get the answer. If we forget the formula, we won't be getting the answer. Marks.
Yes, sir. 12.5.
Just a minute. 12.5
Yes, sir.
seconds.
Yes, sir.
It's 12.5 seconds. Okay.
Yes, sir.
Shall we move forward and solve one more question?
Yes, sir.
Let's do this question.
Yes, sir.
Okay. What is the question telling us? Ask question. What is the data given in the question? A broad gauge. Listen, broad gauge. We have three gauges. What are they in railways? Broad
Yes,
gauge, meter gauge, narrow gauge.
sir.
Okay. Broad gauge, meter gauge, narrow gauge. Broad gauge means G is equal to 1.676 meter.
Yes, sir.
Just a minute. Yeah. Broad gauge itself means how much? 1.676 meters.
Yes, sir.
Line passed through a horizontal curved section. How much is the radius?
875 meters.
875 meter. And length 200
200
meter. Allowable speed on this portion is how much?
kilometer per hour.
100 kmph. For calculating the cant, the gauge's center to center distance, considering the gauge is how much?
1750
If this is not given, how much we should have considered? Tell me.
1.67 meter.
1.676 meter.
Yes,
Okay.
sir.
But when this is given, don't consider this. Directly he gave you the gauge.
Yes,
Yes,
sir.
center to center distance. Because my problem is here my intention is not to make you solve this problem. I wanted you to learn this concept along with the problem.
Yes, sir. Yes,
Okay.
sir. Yes, sir.
So the gauge here is equal to 1750 mm. Maximum permissible cant is how much? That is simple. E is given by GV square by 127 R. What it is, ma?
Yes, GV square by 127.
GV square by 127 R. This is cant C, or you can also call cant as super elevation. Both are same. Okay. What is Z now? 1750 mm is how much meter?
Sir, 1.75 meter.
Into V, substitute V as capital V only. This is an empirical formula.
Sir, 100.
100 square upon 127 into radius is how much?
875.
875. Then what? Why is this length given? No use. Just to confuse you.
Yes, sir. 0.157.
1.75 into 100 square mhm, upon
0.1.
127 upon 875. Is it?
Yes, sir.
0.157. What it is, ma?
Yes,
15748 meter, right?
yes, sir.
But we want in which units, ma?
Mm.
So convert this meter to mm then.
157.48
The
mm.
answer actually in the key is 157.2 to 157.7 mm. Any value in this, you will be getting the answer, marks, full marks.
Okay, sir.
Shall we see one more question?
Yes, sir.
Let's say this. Yes. First, as per ICAO, International Civil Aviation Organization, IRC, Indian Road Congress is for highways. For
Yes.
airport, it is not by Indian, it is international. What it is?
International Civil Aviation.
International Civil Aviation Organization. Elevation and airport reference temperatures of the airport are, how much elevation is 535 meter, airport reference temperature is 22.65 degrees centigrade. Okay. Effective gradient of runway 1%. Length of runway 2000 meter. Within the framework, the length of runway for corrected temperature is, okay. First, before doing the correction for temperature, we need to do the correction for elevation. Are you understanding?
Yes, sir.
Before doing the correction for temperature, first we need to do the correction for elevation. Correction for elevation is 7% increase in length of runway, 7% increase in length of runway per every 300 meter. How much is it, ma?
7%.
For every 300 meter above MSL. What is correction for elevation? For every 300 meter elevation above the mean sea level, you need to increase the length by how much?
7%.
Okay. For 300 meter, we need to increase by 7%. But here, what is the elevation above mean sea level?
535 meter.
So for 535 meter, we need to increase by how much percent?
7 by.
7 into 535 by 300.
Yes, sir.
How much is X then?
Sir, we can substitute directly in percentage here, no?
Yeah.
Okay, sir.
Yes. Because here we are getting only percentage. Then we
Yes,
will
sir.
see what to do then later.
Yes, sir. Sir, to 12.48.
How much is it?
12.48.
Any other value after 12.48?
483.
Okay. 12.483 percentage we have. Okay.
Yes, sir.
Now that is for this 2000 meter. So increase in length due to elevation. How do we do it? Tell me. 12.483 by 100 into 2000. How much is the answer? Why 2000? Total runway length is 2000. For this, we need to increase.
Yes, sir.
How much is it then?
Sir, 249.66.
Okay, let's safely assume it 250 meter.
Sir.
Now, that is what is increased length after increase for elevation. Elevation increased length. How much is it? 2000 plus 250.
Yes, sir.
2250 meter. But we don't want it only for elevation. We want for the temperature. But before directly going for temperature correction, we need to do the elevation correction. That is why we have done this. Yes or no?
Yes, sir. Yes, sir.
Before doing the temperature correction, first we need to know what is standard atmospheric temperature. Standard atmospheric temperature is given by the formula 15 minus 0.0065 into elevation. Okay, this is your formula. This
Yes,
is
sir.
very important. 15 minus 0.0065 into elevation is how much for this?
Sir,
535 meter is the elevation.
yes, sir. 535.
So how much is the standard temperature we will be getting is 11.5225 degrees centigrade. Okay.
Yes, sir.
Okay. Now, what is the airport reference temperature we have?
22.65.
So what is increase in temperature then? Increase in ART is how much? Actually, standard should be 11.52. But we have how much? 22.65. So what is increase in temperature? 22.65 minus 11.5225.
11.1275.
Very good, very good. 11.1275 degrees centigrade. So correction for temperature is equal to, listen,
Yes, sir.
already for elevation, when we applied correction, we got corrected length as how much?
3250 meter.
2250.
Yes, sir.
After applying correction, total length is 2250.
Yes, sir.
Into how much is the temperature?
11.1275 degrees Celsius.
So for every 1 degree centigrade, for every 1 degree centigrade rise, we increase 1 meter length. Okay.
Yes, sir.
For every 1 degree centigrade rise, we increase 1 meter length. So therefore, total we have 11.1275. Therefore, we increase it by 100
11. Yes, sir.
by percentage.
Yes.
We increase it by 1%. 1 degree, we increase it by not by 1 meter, we increase it by 1%.
Yes, sir.
Now, how much is the correction? Hmm.
250.368.
Let's make it 250.
Yes, sir.
So already we have 2250. Total increased length is how much? 2250 plus 250. How much is it?
Yes, sir.
2500 meter will be our answer. Option C.
Sir, the step of in city, uh,
Mm-hmm.
please once again make me understand about this
CT.
step.
Up to, is it 2250 clear to you how we got it?
Yes, sir.
Okay. First, we will calculate the standard atmospheric temperature.
Yes, sir.
That is given by formula 15 minus 0.0065 into elevation. Elevation we have is 535, we substituted. We got the
Yes,
standard atmospheric temperature.
yes, sir.
After that, we will be carefully checking out how much how much more is airport reference temperature in comparison to standard temperature.
Yes, sir.
So we have subtracted 22.65 with 11 points, that is with standard temperature.
Yes, sir.
So we got some 11.1275
Yes, sir.
degrees centigrade. That is, actually the temperature should be 11 degrees centigrade, but the temperature is 22 degrees centigrade. So how
Yes, sir.
much is the increase you have?
11.1275 degrees
Listen,
Celsius.
listen. Already, actually the temperature should be 10 degrees, but you have it as 21. So how much is the increase?
11.
11. Okay. For every 1 degree centigrade increase, you need to increase the length by 1 percentage.
Yes, sir.
So here, I will tell you here now. Listen. For 1 degree centigrade increase in temperature above standard atmospheric temperature, length is to be increased by how much? 1
1%.
percentage. But here, how much increase in length temperature you have? 11.127 degree increase in temperature above standard atmospheric temperature. That's or no?
Yes, sir.
Therefore, length is to be increased by how much percentage?
11.127%.
11.127 percentage. So
Yes, sir.
actually length is how much? 2250, which is after application of the correction for elevation. To
Yes,
this
sir.
elevated corrected length only we need to apply the correction for temperature.
Yes, sir.
Okay, therefore that is 2250 into 11.127. Since it is percentage, I am dividing it with 100.
Yes, sir. Yes, sir.
So I am getting it around 250 meter.
Yes, sir.
This is correction for temperature.
Yes, sir.
Now already we have 2250 for correction for elevation after doing the length for correction for elevation. Plus
Yes, sir.
correction for temperature is
250.
250. So length after temperature correction is how much? 2250 plus 250 is
2,500.
2500 meter.
Yes, sir. Yes, sir.
Understood?
Yes, sir.
Any doubt in this?
No, sir.
So we will stop here for today. Okay.
Yes, sir.